Let's do one more example using this power torque speed relationship, and we're going to do it in the metric system this time, and we're going to turn it around a little bit as well. So here's the problem we have to work with. We have a test chassis in our lab, a little engine that we can hook up to a dynamometer, and that engine is supposed to develop 26 kilowatts of power at a shaft output speed of 540 RPM. So how much torque would that tractor be developing at that point? So now we're going to calculate torque instead of power. So let's tear into this. It's the same relationship, and we put down our equation: power equals torque times speed. That's our relationship. This time we need to calculate the torque. So I need to solve this equation for torque. And it's fairly simple algebra, if you remember how to do that. But basically, I'm going to multiply both sides of this equation by 1 over n. 1 over n over here. Multiplying both sides of an equation by the same thing doesn't change the equation. So on the right-hand side, the speed will cancel off. And that tells me that my relationship is going to be torque is equal to power divided by speed. Okay? So that's the fundamental relationship that I want to start with. Now, when I write an equation down like this, one of the first things I do is say, what units am I after? So I know as I'm writing this down, what my ultimate goal is, what I want to get to. So torque, and I've even asked you that specifically in this example, the torque we want in Newton meters. So the units out here that I'm going to be after is a Newton times a meter. So that's my ultimate goal. So we just start putting stuff in with its units. Okay, so let's look at power. Power is in kilowatts. Now, let's remember that 1 kilowatt is equal to 1,000 watts. Okay, so that's what a kilo does. It just makes it 1,000 times. And that's the same thing as 1,000 Newton meters per second. Okay, so I can utilize those relationships. And so when I put the power in this equation, my power is 26 kilowatts, and I could just make that 26,000 Newton meters per second, or I can write it down and go through all those conversions if I want to make sure I don't make any mistakes. So let's go ahead and do that. Let's write it all out. So I have 26 is my unit, and that's a kilowatt. And that's over 1, since there's no units underneath that. We just put that over 1 to make it a fraction. So that's the power, first thing I put in there. Okay, and my speed is 540 RPM. And if you remember, RPM is a revolution per minute. This one has to go in the denominator. The n is in the bottom. So we put 540 in the bottom, and that's the revolutions per minute. And the per minute then will end up in the numerator of that equation. So that's my equation, 540. So we're going to have to figure out what to do with that kilowatts. So we have to do something with the minutes, get rid of that, and we got to have this revolution to get rid of as well. So a lot of units work to do here. So let's start into this. Let's tackle this kilowatt. So what is a kilowatt? So to get rid of the kilowatt, so I can put 1 kilowatt in the denominator, because that's what I want to get rid of. I can cancel that from the numerator. For every 1,000 watts. There you go. So the kilowatt is going to get canceled off, and I've got rid of that. So what do I do with the watt? So 1 watt, again, I want to get rid of the watt. The watt is in the numerator now, so I'm going to say 1 watt in the denominator is the same thing as 1 Newton meter per second. Now, the Newton meter was in the numerator because I was the opposite of that. So I started with the 1 watt in the denominator. For every Newton meter per second then goes back down on the other side. So it ends up in the denominator. So I have a Newton meter per second. All right, so the watts are canceled off, and I've got rid of that. So what do I have left up there? Let's look at this. So in the numerator, I have a minute up here that I've got to do something with and get rid of. I have my Newton meters. That's what I want. So what do I have in the bottom? I have a revolution in a second. Okay, so look at this. I have a second down here and a minute up here. If I can do one of them, convert seconds to minutes or a minute to a second, then I can get rid of those two. So let's use our minutes per second conversion. And I'm going to say in the numerator, 60 seconds for every minute. There you go. Now look, I have a second in the numerator that cancels with a second in the denominator. I have a minute in the denominator that cancels with this minute in the numerator over there. Then I have rid of everything. So my numerator again going across there, it's all canceled off except for my Newton meters. In the denominator, it's all canceled off except for this revolution. What in the world do I do with revolution? Oh yeah, that was that radian 2 pi trick that we used to get rid of revolution. So I multiply this by 1 revolution for every 2 pi, and that was 2 pi radians. We ignore the radians. We consider that to be unitless. So let's just leave that like that. So that revolution is going to cancel off. And look what I'm left with. Wow, so I've got a lot of stuff that I built in here. Again, these first two pieces were the only were my equation here, the power and the speed. The rest of this is all making the units work out. And I've got left the Newton meters that I wanted. That's what was my goal from when I start with. So now it's calculator. Multiply everything in the top, divide everything in the bottom. So the calculator sequence would look like 26 times 1,000 times 60 divided by 540 divided by 2 divided by pi. And if I do that, the answer should come out to be 460 Newton meters. That is my torque. So that's how we do that. Again, units works the same way in the metric system. You look at what you got and you go piece by piece, and how do I cancel and change and convert those units to the units that I need? What was my ultimate goal down at the end of that equation? And that's how we come up with that answer. So again, I could have looked up an equation somewhere that had this conversion in it, but we know we'll never make mistakes. We'll know we'll never put the wrong thing in if we do this units conversion ourselves and make it all work out. So that's how to do one in metric system.